Alright, Chapter 8, Control Products and Pipeline. Chapter 8, Control Products and Pipeline, Field Manual 1067-1. Interface control. Pipelines have between bulk terminals, multi-product product lines. Problems caused with the pumping more than one product through the pipeline involve the mixing of the products to swivel the mixed portion interfaces. Product with a different product with the interfaces must be valved so that the products can be taken off the line at the right place. The volume interface depends on the difference, gravity, viscosity, adjacent products on the pressure of the velocity of the stream, and also depends on the interior condition of the pipe, the number of the pump station, the distance traveled by. Interface, the difference in gravity, the viscosity will also affect interface disposal. Interface size can be reduced, maintaining pump rate needed to keep the heaviest product in the line. Turbulent flow size can also be reduced by putting products in the line. Proper batching sequence by keeping line pressurized during shutdown. Positive pressure will prevent speeding of the interface. The interface volumes will be cut down whether the interface stops on level ground or on a slope. Principle of pipeline hydraulics are covered in Appendix C, page 6C7. Flow products. There are two types of flow in the pipeline: laminar and turbulent flow. Figure 8.1. Laminar flow, smooth with a streamlined flow with which product of the pipeline will flow in concentric layers. Turbulent flows across the when velocity flow increases beyond the critical velocity of the layers disintegrate. Two types of flow can be shown with the pumping colorless liquid into the glass pipeline. A colored liquid is injected into the pipeline. The flow can be observed at the point downstream. At low viscosity, the color seems to flow in the streaks and straight lines. A streak are actually a concentric layers arrangement of layers referred to as laminar flow. A velocity that increases the laminar flow continues streaks waver, break into slightly different pattern. B, figure 8.1. This point with a critical velocity is higher than critical streak with the dispersed and random throughout the stream. C, figure 8.1, the referred to turbulent flow. The both types of stream velocity varies from 0 to pipe wall's maximum center. B, D, and E, figure 8.1. Mean velocity and laminar flow of 0.5 maximum velocity with the mean velocity turbulent flow of 0.75 maximum velocity. Velocity curve flattens in turbulent flow. The batching product shows how much less tail product penetrates the head turbulent flow and then laminar flow. The pipeline kept in turbulent flow at all times. Smaller volume interfaces formed. Use limit. The disposition interface is determined by product use limits. Often specification products whose qualities fall within established limits may be used for intended purposes. Consent, which a product can be shown safely thrown off specification, determines how much adjacent product can be blended with it. Military handbook 2 is again an application for these use limits. Shows A, low viscosity, B, critical velocity, C, higher critical velocity, D, mean velocity laminar flow, mean velocity turbulent flow. Mean velocity. Alright, batching products. Products lightly batched with military multi-product pipelines include MoGas, kerosene, jet fuels, diesel fuels, figure 8.2. Exact batching sequence is not fixed. However, batches should be arranged in critical product with the produced interface that can be used with closely related products adjacent to ascending order with the quality with the gravity. Provide most clearly related quality have been lost. Least difference in gravity of the form and interfere with the spread less than the distance traveled. They are more easily disposed of the one or both adjacent fuel. The method of the batching simplifies quality surveillance. Disposal of the interface are simplified by the making hard cuts for the delivery along the line. Hard cuts are portion of the pure product taken with the line before and after the interface or intermediate terminals where the hard cuts are made with the final terminal where any of the product and only waste of the interface are handled. When complete batch is taken off of the intermediate point, the interface must be taken off also. Preceding following batches are brought together with as little mixing as possible. The quality surveillance officer of the chief dispatcher give the instructions on disposing interface. Batch indication, batch changes, batch residual described below. Batch designation. Product numbers of the form. The first part of the numerical bath designation batch numbers form. The second part, for example, to 121. Batch designation. 21st batch MoGas pumped since the first of the official year. Product code number. The pumping sequence may be numerical order. Figure 8.2. The batch numbers are assigned for each fiscal year, beginning with the number 1. First batch at any fuel pump station record the number of the passing batches at all time. The time of each of the batch change is recorded and reported to the dispatcher. Should the low string code numbers MoGas, JP4, kerosene, diesel fuel, kerosene, 1, 2, 3, 4, mixture MoGas, JP4 should be cut in MoGas 1. Mixture JP4, kerosene should be cut at number 2, 50% in both. Mixture kerosene, diesel fuel should be cut in the midpoint 50-50. Directions of batch changes. The control of the product flow over the pipeline must be determined with one batch and with another batch. Begin with the flow method to detect with the batch changes. Pipeline gravity difference. Both change with the detect with the difference. Gravity 2 adjacent product with a maybe greater difference between the MoGas JP8. There may be little difference between diesel fuel 1 and 2. Figure 8.3. Color change with the both change with the detect difference. Color 2 adjacent product with a maybe greater difference. Color almost no difference. Liquid buffers. Kerosene or some neutral product in a relatively small amount may be used with a liquid buffer to separate incompatible products with owners, not used to separate products. Physical buffers. Physical buffers an object such as a pig, rubber ball, a scraper, controlled trolley polyurethane placed in the line to separate batches cut down with the interface to drive die plug. Plug die is injected into the line, separate line-like products before different customers also use separate similar products, little or no color difference, such as the diesel fuel 1, diesel fuel 2. Batch residuals. After delivery to an idle pump at the station, shut down fuel station delivery lines, dead ends of pipes and manifolds. Pipe 6 and 5/8 of an inch in diameter holds about 1.5 gallons per foot, and fuel is delivered in line should be displaced as much as possible per new delivery as started. Pumps and pumps manifold idle stations may have 5 to 6 barrels of fuel. Residuals should be kept during current with the clean changing batches, so that not pumped into the line with the wrong time pump station. Not only the line should be started up just before each batch changes, idle the through change to flush the system. Just typical gravity range, diesel fuel kerosene JP6, JP5, Jet 4, MoGas aviation gain. Specific gravity ranging from 1.0 to 8251 and 7022. Alright, switching procedure. Protection of the production specification pipeline shall begin with the line leading into the base of the terminal. Product before receipt of the line should be free with the product received earlier. It can be displayed with the fuel of the discharge for the next tank of air water, not be used with the displaced fuel with the setting on the loading lines. There must be clean interface with the new product started within the pipeline. At this point, dispatcher inch of the total amount of the receding product pumped into the line with the opening of the gate of the new product. With the opening gate was made before the switch closing gauge. The old product must be made immediately after the switch. You the rule flying switches are made in the batch chamber. The interface area arrive at the operator close with the one tank valve while the another operator opens the tank with the valve with another tank making a hard cut. There is precision operation period of time which for the both valves are open must be short possible. However, the one valve must open before the other is closed. Hard delivery proceed with the interface length the quickly as first start with the downstream of the pipeline. The farther the travel the down line with the more slowly at length. About 65% of the total interface between two products will occur within the first 20% of the pipeline distance of the dispatcher given to each station. Expect the arrival time in the interface each station report the first final charge of the color and gravity of the 1 minute interval across the interface. Delivery to storage of the branch pipe. Intermediate points should be made with the hard cuts. Main concern with the station setting and the proper valve determining the interface is passed. When sampler opens the delivery valve of the branch line, when the fuel is taken off of the rate with the time directed within the dispatcher, flying switches even delivery. However, the method of disposing interface completely with switching procedures at a final station. Product cuts. There may be many times product cuts are needed. A number of those factors that must be considered making such cut. There are 3 ways of disposable interface ways depending on the type of the batch chain with its valves. All mixture cut into one or another adjacent product with the project protects critical procedure products creates an unusable interface with the dispatcher should determine the percentage of each of the product interface to be cut in adjacent products. Mixture divided between the 2 adjacent products usually eliminated by gravity point with provides minimum contaminant product both products. Blending tolerance as considered with the dispatching personnel should determine the percentage of each of the product interface to be cut in adjacent products. The whole interface taken off of the line with a slop tank and is blended with the incoming product with the later with the mixture become with the new product with when its own identity. Dispatching personnel should determine the percentage of the product slopes of the slop tanks that are to be used in blending. Terminating time of the cut. The type of the badge change that may determine the right time to make the cut. Line sampling station, the distance upstream of the pipe manifold, the distance equal to the specific time interval, usually about 15 minutes normal flow rate. Rate of flow of the interval is not specified, but it should be known as representative of the time available to prepare the cut. Also, internal interval determines the actual time of operation. Or preparing color change. Preparing color change with the sample should be taken with the sample of the line chamber. They expect with the beginning with the sample the first change of the dome of the active success with the sample to take with a 1 minute interval of the sample to arrange in order to take the definite time of the can be fixed with the first final change. Preparing gravity chain. With preparing gravity chain, the terminal operation off with the dispatcher give with the station and the corrector with the API gravity give with the tube drive with the gravity is converted with the gravities at all existing line temperature. This gives the complete gravity range through the batch change will take place. The gravities must be converted each time the line temperature changes. Observed gravities and times are recorded with the first change to the final change, figure 8.4. And then it shows your batch change record base gravity readings time intervals. Preparing for color and gravity change. Preparing for the color and gravity change. Color and gravity are observed with expected for the time of the change. The terminal operator for the dispatcher for the set with the time of the freak for the observation. Burning it forward during the batch change suggested procedure the beginning to take reading 20 minutes before expected arrival time of the interface sample should be taken in 5-minute intervals. Begin 5 minutes before expected arrival time. Samples are to be taken each minute. When interval arrive, samples are taken at the rate of 2 or 3 per minute. When samples are taken at intervals 1 minute or less, the sample line may be left open and flowing the inch of the representative of the sample during the actual change. Making the cut. Terminal operators, officer of the dispatcher issues instruction for making cut. They are based on the pattern shown in table 8.1 sample watching batch change of the key person operation time. Comes sampler assistant operates the valve to be made cut. Batch changes. MoGas JP4 fish gravity 4 JP4 MoGas last gravity JP4 JP4 kerosene first good gravity kerosene diesel fuel last good gravity of kerosene diesel kerosene mid gravity MoGas kerosene first good gravity to kerosene diesel mid gravity point diesel to MoGas last good gravity of diesel MoGas to diesel first good gravity to diesel. Or batch changing records, observation gravity change report passage interface making delivery cuts pay for the displacement meter readings time interval with the hydrometer for the time of the first for the last gravity reading with the rate of flow should be reported with the dispatcher information fixed exact time of the interface passes. Also show the link with the volume interface with the format with the batch change the record with the prescribed with the chief dispatcher. Suggested formats are shown figure 8.4 page 85 and 8.5 page 87. In both cases of the first reading record, last reading of taken before the first change is noted. Displacement meter, hydrometer, figure 8.5 and 8.7 is example of batch change record with a bin displacement meter of the hydrometer readings. Batch change for gasoline is 64 degrees API 0.7136 specific gravity to the kerosene 40 degrees API 0.8155 specific gravity. Purpose of the chain with the make with the hard cut delivery with the interface has path with the takeoff with the point. Changes cover the specific gravity range 0.10198 to 8155 minus 7136. Line temperature 38 degrees Fahrenheit. Gravity has been observed with the 1 bar intervals. Volume composition interface complete. Computed as follows. Specific gravity increase with the 10 point first 10 barrel increment with the meter reading of the 371,590 barrels. Specific gravity is 0.7136 representing the per gasoline. Specific gravity 0.8155 represents pure kerosene. Therefore, 10 point increasement represents 10 divided by 1.019 times 100, 1.0% kerosene or 0.110 a barrel in the first increment. Gravity increase 2 point second incremental total increase to 36 point. Therefore, second increment is 36 divided by 1,119 times 103.5% kerosene. Percent of the total gravity increase for the corresponding amount of the kerosene computed in like manner within much each increment. Based on gravity alone, the 19th 10 barrel increment 99.6% of the kerosene lasts for the gasoline. Total barrel column of 115.97 barrels of kerosene. Interface 190 barrels. Interface has 61% tail product, 39% head product. Flashpoint test shall show that even the good kerosene have reached enough gasoline stays lower flashpoint kerosene dangerous level. The 100 barrels added to before the cut is a safety precaution which has taken to remove the hazard. Figure 86, page A8 should be graphic shown with the same batch chain with the point A beginning with the interface meter readings of 371,580 barrels. Point B, approximate end of the interface meter with a reading of 371,770 barrels. Point C, with a cut point meter reading of 371,870 barrels. Area D represents volume of the gas interface. Area E represents volume of the kerosene determined by gravity. And it shows the table with a batch chain record displacement meter gravity readings. 86 shows the graphic showing a batch change, gasoline gravity area, flow stream area, and kerosene gravity A, B, and C. 190 barrels, 100 barrels. Alright, mid-gravity point. Figure 8587 shows a sample of the mid-gravity cut point. The mid-gravity cut point reach 8th of the 10th barrel increment metering of 371,660 barrel with a percentage varying middle of the gravity cut divided intervale with the two unequal part of the smaller part of the next of the head product consists mainly head product, larger part of the next of the tail product consists mainly of the tail product because of the gravity of the tail part is heavier than the gravity of the head part of the tail. Most products tend to penetrate the head product. The 9/10th barrel increment of 53.2% of the tail product. The barrel column is 17.10 barrels of a tail product at this point. Therefore, 80 barrel part of the interface would go to the tail cut product section. Tankage at 98.87 barrels. Tail product 11.13 barrels of head product. Mid-gravity is mentioned gasoline, kerosene for illustration only. Such cut would be not in place in practice, would be necessary to protect the octane number, the vapor pressure over the gasoline flash point of the kerosene. Time interval and hydrometer figure 84, page 85 show the batch chain record based on the observation gravity fixed time in the interval 1 minute batch change shown in the kerosene is from kerosene 42 degrees API, gasoline 60.7 API. Reads a good have changed record same way the figure 85, page 87 to compute the volume composition of the interface record with the adequate record passage interface for a cut when interface is passed. Alright, analysis batch change report. Data recorded on figure 84, page 85 can be made in the same kind of information shown in figure 85, 87. Information table 82, page 89 has been computed as follows. The gravity differential 61.2 minus 42.3, 18.9 degrees. First gravity change of the 2019, final change of the 2020, 40. This period of 21 minutes of the 2,800 barrels per hour with the interface volume of the 980 barrels. This is about 46.7 barrels arriving each minute. Percentage volume of the gasoline computed with the increment. This is in figure 85, page 87. The total amount of gasoline interface of the 560.85 barrels this is a 57.2% of the tail product compared to with 61% of the tail product in figure 85, page 87. Table 8 2 show the analysis of the batch change report. Time taken, corrected gravity, gravity increment, total increase, percent of gasoline, and barrels. Chapter 9, Pipeline Operations.